Although we wish you could have joined us here in Waterloo, we are so excited and thrilled to welcome you from various locations throughout Ontario, Canada, and even the United States. Our Waterloo engineering network is wide and continues to grow all the time. There are now more than 50,000 Waterloo engineering alumni making a real positive difference in our world. As the Dean of Engineering, I do have many opportunities to be proud of the people and work that emanates from our faculty. The Engineering Ideas Clinic is one truly exciting example of this. The first of its kind in the world, the Ideas Clinic has proven to be a game changer in terms of our students' education. And many of you on the call tonight helped us build it from the ground up, which is so exciting and I am truly thankful for. Your extraordinary support and ongoing commitment are truly inspiring, and we want to thank you for that. Without your investment, the building of this novel concept and unique program, as well as this dedicated space in our E7 building for students to create, test, refine, and succeed wouldn't have been possible. You've given them a chance to try engineering in this Ideas Clinic. Later in the program, some of our talented co-op students will join us to showcase a few projects they've been working on with the resources, programming, and experiences made possible by the Ideas Clinic. Programs such as the Ideas Clinic have positive learning outcomes for our students as they work on their technical expertise. And I did happen to visit some of these activities this term, and I could see the fun the students were having. And when you combine fun with learning, you know you've got the right ingredients for success.
Good afternoon. My name is Chris Rennick. I'm the Engineering Educational Developer with the Engineering Ideas Clinic. And welcome to our first floor design studio with the Ideas Clinic here in Engineering 7. With the projects we're about to show you, these have a bit more of a sort of upper year focus, so they're sort of aimed more at second and third year. And so they have kind of a more multidisciplinary and a much broader sort of perspective of engineering. The first project that we're going to show you is part of our life cycle activities. And with this, we wanted to show students parts of the design process that they're not likely to see even on work terms. We wanted to show basically the full sort of active life of everyday project or of everyday items. So we have both an armchair and a bike frame that you're about to see. And with this, we basically wanted to create a way of sort of combining modeling and simulation and experimentation to show students how all these pieces sort of come together in the design of everyday items. So with this project, I will sort of step aside and let my two co-op students, Kashin and Mayura, tell you a little bit more about it.
Hey everyone, I am Mayura, and I've just completed my 1B term in systems design engineering, and I'm currently working as a co-op student at the Engineering Ideas Clinic.
Hi, my name is Kashin, and I just finished my 2B term in biomedical engineering, and I'm also a co-op student working at the Ideas Clinic. So as Chris mentioned, today we're going to be going through the lifecycle testing project, in particular 2 of the devices we've been working on, the chair testing machine over here, and then the bike frame testing machine. So Maria is going to explain a bit more about the chair testing setup.
So as you can see, here is the chair testing machine, and it is basically made with a bamboo frame, and it is an IKEA armchair. So how it exactly functions is that here is a linear actuator that basically extends and pulls on to the load cell until like a specific force is applied to it. There is a limit of about like 40 kilos, and the user can also select how much load they would like to apply and the number of loops they would like to cycle this setup for. So the main purpose of this was to basically understand how the chair like deforms and changes under varying loading conditions. As you can see, this is the LED strip that basically allows students to easily understand and observe how the chair deforms when different loads are being applied to it. So now we have also designed a CAD model, and we have also the students can also run a simulation of it through the ANSYS software that again allows students to digitally observe how the chair deforms under varying loading conditions. So now we are going to show you a demo of the armchair.
So I'm just going to set up the demo quickly. So we have a 12-volt connection here, and then we have our Arduino code set up on the laptop here. So that's going to just communicate and power the actuator and then demonstrate how the device would work. So as you can see, the LEDs have lit up on the side. And I'm just uploading the code now. So as you can see, the chair is moving up and down, and you can see how the extrusion up here attached to the load cell is pushing the chair up and down. And then this black button that I have here is just an emergency shut-off switch, and it's an added safety feature just in case. So the cyclic loading model that we have set up is fairly well, and it gives good experimental data for students. So our next steps are looking into making it more interactive for students when they're collecting their data. So we're looking at adding some different load sensors. So we've ordered a few different ones. We've got a square patch that would measure the force that's applied at that particular point. And then we also have flexing resistors, which would measure the bend radius to see how much the chair deforms. So we're going to be experimenting with that as our next step. And then hopefully students will be able to collect data if a human load is applied, as that's more inconsistent than having a constant cyclic load being applied. And then one more thing I want to mention as well. Another co-op student is working with the Microsoft Azure software. So that's set up in the back over here, just behind Mayura. So he's using image analysis to track the chair movement using LEDs or the reflectors on the back, which you can't see. But he's using that to help predict how the chair would deform. And then this would also help with better product design.
So this is another project we have been working on, which is the bike frame testing machine. So as you can see, it is shaped exactly like a bike frame, and it is currently made out of steel. So just like the chair testing machine, it basically has a linear actuator that extends and retracts until a force is being applied to the load cell. So this is done just to simulate a crash scenario, like when the front wheel of the bike hits onto something like a curb, and then the front part basically is pushed inwards. So that's the whole purpose of this bike frame testing machine. And then just like the chair testing machine, the user gets to input how much load they would like to apply and the number of cycles they would like to apply the load for. So this allows the user to observe any changes or any deformations the bike frame is going through. And another thing is that this setup can also be compared with the high stress points, which is found in the finite element analysis simulation model. And this is done virtually. So this ideally allows students to make material or design choices digitally without any physical prototype. So our next steps with this project is that as this bike frame is working pretty well, we're going to go ahead and modify this design by selecting materials that can clearly show how this frame deforms under several conditions. Yeah.
Yeah, so we hope you enjoyed hearing about these projects, and we just want to say thank you to everyone who has donated and supported this project. We've learned a lot of valuable skills through this, like soldering components, making electrical schematics, how to read them, working with Arduino, and just the overall struggle that's associated with the engineering design process. But we're very thankful that we've gotten a chance to work on it for the past 2 months, and we look forward to continuing to work on it. Thank you.
All right, so just to sort of add one last time, this project behind me is only possible because of the support of folks like ANSYS and Microsoft, who have contributed very directly to this particular project. This project behind me we've used in both the undergraduate and the graduate curriculum. So it's had some great uses so far, even though it's sort of only been available in this calendar year. Okay, well, we're going to move on to our second demo. This particular project you're about to see is one of the conveyors as a part of our industrial automation hub. This has been sponsored by Brock Solutions. We've worked with them for the last 2 years. And really what we've been trying to do in very close partnership with engineers from their company is to design a project where we can show students a snapshot or sort of a glimpse of that industry. So we want to kind of bring a taste of what it means to be an industrial automation engineer into the classroom. And it's really great for us because it's a very multidisciplinary domain. It has broad interest from electrical engineering to software engineering to management engineering as these systems start getting larger and larger. This particular project has also had the support, as Sanjeev mentioned, of both Opto22 and Inductive Automation, who have given us sort of the ability to control these sort of progressively larger systems. This particular project has been used in the undergraduate curriculum in both first and fourth year, and over 500 students so far have sort of engaged in activities that have derived directly from it. And with that, I will hand things over to Jason and Shivam, who will tell you a bit more about it.
Good evening, everyone. My name is Jason, and I'll be heading into my third year of mechanical engineering here at the University of Waterloo.
Hi, my name is Shivam. I am in third year mechatronics engineering, and we are basically the industrial automation team, and this is very exciting.
Yeah, so right now we're actually missing one of our teammates. His name is Cooper, and he's been working on this project with us too, but he's kind of come down with a cold, so he can't be with us today.
Yeah, so here in front of you, you see is the conveyor system that Professor Betty mentioned. And as you probably know, a conveyor system is one of the most common components in any factory, in any modern factory. So the goal with this project was to allow students to see and manipulate a small version of a conveyor system in the classroom so they can see how different components interact and how one would go about controlling such a system. So, and as Professor Betty also mentioned, this conveyor is quite a multidisciplinary system because it allows us to demonstrate concepts in mechanical engineering, in electrical engineering, in software engineering. So for example, like if you look at the belt driving mechanism or the structure of the conveyor, those things are very relevant to a mechanical engineer. While the sensor, like the way the sensors interact with the PLC and or the way we control the motor speed, those are concepts that are very relevant to electrical engineers. And then we also have this camera, which is really good for, we use for computer vision, and which actually is a really good place for software engineers to use their skills to modernize these factory setups. So
yeah, so with that, I think we're going to move on to the demonstration of how this conveyor works. So we kind of have two main modes of operation for this conveyor, one being manual and one being automatic. So in manual mode, the conveyor allows for an operator, which is typically the student, to control the conveyor manually. So here we have a manual panel with a few different switches. So I think the most important feature of this manual panel is this red button, which is our emergency stop. So if for any reason something goes wrong or a student feels the need to stop the conveyor, then they just press this button and it cuts power to the circuit, so everything will stop. Other features on this manual panel is this three-way switch. So this kind of switches between our three modes: automatic mode, off, and manual. So right now I'll demonstrate how manual mode works. So I just have to switch this three-way switch here to manual. And we have a few rocker switches, one being to control the belt, and whether it goes forwards or backwards, and one to control the diverter arm. So the way I'll demonstrate this is I will put a box onto the conveyor, and then I will press one of the rocker switches to move the belt forward. And then once it reaches this point where the diverter arm is, I will press the rocker switch to actuate the diverter arm, and the box will move from the conveyor belt onto the platform. Yeah, so that was just a really simple demonstration of our manual mode. So that's actually not the primary mode of operation. The one that we focus on the most is our automatic mode. And that's what the students in the lab use to develop their lab, and that's typically what they work on, is the automatic mode. So the automatic mode allows students to program and to tell the PLC what to do under certain circumstances. And the manual panel doesn't need to be used for that, and that's where kind of the programming side comes in. So to show the automatic mode off, I'm going to put different shapes onto the conveyor, and then based on which shape I put onto the conveyor, it will be diverted. So the shapes I have here is I have a pentagon. Yeah, so I have a pentagon, I have a circle, I have a trapezoid, and I have a triangle. So I will put on the pentagon and trapezoid first, and those will not divert. And then when I put the circle on, it will divert. And the triangle, which will come after the circle, will not divert. So, yeah, so that was just a little quick demonstration of our automatic mode. And I think I can speak for everyone on this team that worked on this project that we learned so much from working on this project. One big thing that we got the chance to do was hands-on mechanical assembly. So we kind of built the system up from scratch, putting the aluminum extrusion together and all that, tightening the nuts and bolts. And one really big thing that we learned in this project was kind of how to use the machine shop. I think coming into this, me, Shivam, and Cooper, our other coworker, we had very limited experience in the machine shop. But after, building these components and using things like the lathe or the mill or the bandsaw, it was a really fun experience learning how to use all of that. Another thing that we learned a lot about was electrical assembly. So not only did we have to do the circuit assembly, but we also had to do the circuit debugging. And that was a really time-consuming task, and it was really tough in the beginning, but we got used to it, and it was also a really great experience. And I think one of the more fun learning experiences that we had was soldering. Coming to the Ideas Clinic, I don't think any of us had any idea how to solder, and we really picked up on that quickly, and it's a really fun experience that we all enjoy. I think another big thing that we learned here at the Ideas Clinic with this project was PLC programming. So in class, we learn a certain type of PLC programming that we don't use here, but we use a more modern approach to PLC programming in Node-RED, which is kind of like a flow-based PLC programming software. And that was a really big learning point for us.
Yeah, actually, this reminds me, we kind of forgot to mention a very big component, which which is actually one of the more cool things that this conveyor system can do. Obviously, you might be wondering, one conveyor system is definitely not enough to simulate a factory environment. We considered that as well, so that's why we actually have a 4-conveyor setup. So what happens is this is a unit of 4, and the way that works is the other conveyors actually interface with it, and we actually get the students to work on. We get the students to basically make a system where each conveyor communicates with one another, which is where we get them to think about ideas of autonomous. We get them to think about conveyors where there's no humans to control it, and the machines are talking to one another. And then there's also the fact that with the push towards Industry 4.0, we've also been looking into getting these conveyors to connect to the cloud, so that we can allow students to learn about supervisory control using IoT. So for that, we use this tool that inductive automation provided us with, called Ignition, which allows students to develop a human-machine interface, which they make themselves, and they can use that to control the conveyor remotely, which was another really interesting learning experience, because students like us, we don't really get to use a tool like Ignition until we get to the workforce. But in developing this, we got to learn about it much earlier, which was really nice.
Yeah, so I think with that, we'll pass it back to Chris.
All right, thanks, you two. One of the things that I want to mention about our industrial automation setup, we have developed this conveyor, and it's getting its first sort of really impactful uses in this fall semester where everyone's now back on campus. And we had some sort of requests from other programs like chemical engineering saying, you know what, this is fantastic. We really want our students to see this technology, but conveyors don't really fit our domain. And so one of the things that we've been working on very recently that isn't sort of ready to show is actually a hydroponic setup. And with that, we can sort of show fluid flow and pumps and tubing and all that sort of thing using those same PLCs and the same sort of underlying architecture. So the flexibility of that has been really great for us as well. Alrighty. So moving on to our third project. Like Sanjeev mentioned at the beginning, one of the things that we sort of are starting to see is that electric cars really are the future. And I think for our own students, if we want them to go into that sort of space, we need to provide them with sort of the starting point for that while they're here on campus. So we wanted to sort of bring an electric vehicle platform to the classroom. The problem that we have, electric vehicles are sort of high voltage, high power sort of setups. They're a little dangerous to bring into the classroom. They're big and they're bulky. So we needed something like the conveyor that's a little smaller that we can actually sort of bring into a space like this Ideas Clinic studio. So with that, we sort of developed a 1/3 scale car. And without further ado, I will turn over to Spencer, our co-op student, to show you around the car a little bit.
Good evening, everyone. I'm Spencer. I'm the lead Engineering Ideas Clinic Research Assistant on both the go-kart project and the motor testing benchtop project here. So the Ideas Clinic, as Chris has mentioned, has 3 main vehicle projects, a small-scale autonomous RC car, the medium-scale go-kart, and motor testing benchtop setup. And we also have a large-scale electric Porsche and benchtop setup with that as well. The main purpose with having all 3 of these projects is to scale up the technology. So eventually we'll be able to have an electric and autonomous Porsche. And these projects were created to allow students who have an interest or are interested in a career in electric vehicles to be able to see how electric vehicles work, get some firsthand experience, and really see how to do stuff with them and how to learn from them. So first of all, I'd like to thank Mengwa for the generous donation that made this electric go-kart project possible. And the electric go-kart features a 500-watt DC motor right over here. We also have a throttle pedal potentiometer, which allows us to control how much power goes to the motor. We also have a drum brake system right there as well, spring and dampener suspension setup. And we also have a reverse switch, so we can go forward and backward. And we also have a big steel tube roll cage for safety. The frame of the go-kart is made from aluminum extrusion and T-nuts, which allows students to easily assemble and disassemble the go-kart so that they can see how it's put together and so that they can understand how to assemble aluminum extrusion themselves if they wanted to do a project with it. So this whole electrical system is powered by 2 of these big 12-volt batteries in series, so we have 24 volts running the system. And to make sure that our electrical system is both fire and electrically safe, we have a variety of quick connects, fuses, and then we also have a relay power switch for the battery cutoff. And we also will have a big red battery cutoff emergency switch shortly, but that order unfortunately hasn't yet arrived. We also have a voltmeter down here, which allows us to see how charged the batteries are. And for those of you wondering, this go-kart is not overly quick, but it does have a top speed of around 18 kilometers per hour. So the next steps for this project are to build an enclosure for the rear of the car so that we can keep the electrical system enclosed just to prevent any accidental contact. And we also want to convert the throttle system that I had mentioned earlier to a drive-by-wire system. This will allow us to prepare more for our transition to making the go-kart autonomous. And while the go-kart is a great demonstration tool to show students how to wire electric motors and how it works inside a go-kart, it doesn't really show them very well what all the parts are and how everything's wired, which is where we come to the benchtop setup. So this setup shows students quite easily where everything is wired to, what parts you would need, and how this is all done. So this is really built to show off how you would wire a system like this. So the benchtop setup has 2 motors and 2 motor controllers. We have one that will just be driven, and the second that has a regenerative braking capabilities. So we use the second motor like a generator in this case, so that we can recover some of the energy that we use while powering the other side of the motor. And also by having it set up this way with the motors chained together, by using that regenerative braking feature, we can vary the load that we apply to the first motor so that we can see how the motor performs under load and then get an understanding of how it works. The electrical system in this, as I mentioned, is quite similar to the go-kart. The only main difference is that we have these control boxes. So rather than having a throttle pedal for a desk setup, we have these control boxes that allow us to turn on and demonstrate the systems. And yeah, that's about all I'll say on the benchtop setup. Working on these projects has really given me the opportunity to learn a ton of really valuable skills, and I'm really grateful for the opportunity to have been able to do so. These projects have taught me how to make electrical schematics in AutoCAD, how to wire and design circuits for electrical and fire safety, and how to solder both wires and circuit board components. I've also learned how to go through the part selection process, the engineering design process, and really just how to build really complicated and interesting projects. So I really do thank the Ideas Clinic for that opportunity, and I thank you for your donations that make these things possible. And with that, I'll pass it back to Chris.
All right. Thank you so much, Spencer. So that was our 1/3 scale go-kart. We're very excited for that. It's going to be used in its first design day activity in the winter term with the first year mechanical engineering students. So really excited to seeing that sort of in the hands of a whole class worth of students. All right. Well, we're going to show one last project. This one is a little different in sort of size and scope in that there actually isn't sort of anything physical to show you. This is a digital project. This started back in the winter semester. And basically, we had some software engineering students on our team who really wanted to sort of learn about cell phone app development. So while we were sort of batting around some ideas for that, we wanted to make something that would be impactful and that could see use on campus with their fellow students. So the sort of route that we ended up taking was looking at student mental health and at ways of sort of supporting them passively. So this app that Anthony's about to tell you about is for deep breathing and mindfulness. And he will set up just a quick little demo here to show you what we've put together. We're really excited about this one. So with that, I will turn things over to Anthony.
All right, hi everyone. So my name's Anthony, and I just completed my 2B term in computer engineering. So for this term, I'm actually taking up a task called the Deep Breathing Project. So as Chris mentioned before, it is a mobile app. And the purpose of this is to teach people how to utilize deep breathing. So this was a project that was created during the winter term, and it was inspired by a group of software engineering students that wanted to create a mobile app, but also wanted to create an app that made an impact. So in this case, they chose to go with deep breathing. So deep breathing is an exercise that is utilized by people in order to regulate their breathing and their heart rate in difficult situations. So for me right now, I'm not gonna lie, I'm kind of nervous, so I utilized deep breathing before this. And yeah, so pretty much, it can be used to relieve stress or panic at any time. And really, it's an awesome tool, but is usually underestimated by people. And it's used in high intensity situations, such as sports like athletes or firefighters, or as I just mentioned, me. So as a student, I feel like mental health is really important, and as a COVID situation has become even more prevalent over the last almost 2 years now. And COVID in general has been very degrading for everyone's mental health, and I can vouch for that personally. As a student that has studied through many study terms online now, I've been confined to my room many times, and it's just been very degrading overall because I've been just sitting in my room for 5 to 8 hours, and it's not really good for my mental, to be honest. And there are many ways to help with mental health. And one of the ideas that was pitched is deep breathing. So for this term, we have created with this term and the previous term, we have created the Shanti app, which Shanti means peace in Sanskrit. So I'm currently sharing my screen right now, so everyone can see that. Yep. So it looks like this on the tutorial page. Very cute. And then you click next. It says understand the features. And you click next again. Obviously stay safe. And note that this app is not a substitute for medical help. So if you do need medical attention, please seek it if necessary. So this is the home page right now. If you notice, it might be kind of bare bones. But it still is a work in progress. And one of the end goals that we have for this term is to actually complete everything. So one of the biggest functions we have on here is the panic button. And if I click on it, the big red one, you can see there's a hold time, and then there's the exhale time. And as you can see, there's also an animation on the screen. So basically, the circle fades in and out. And as it does, you practice your deep breathing with it. So it kind of guides you along in difficult situations, and it teaches you how to breathe properly. So you might be asking, oh, why would anybody want to use like this deep breathing app? Like everyone can breathe, right? Like it's naturally. Well, that's what you want to think. But in terms of difficult situations, not everybody realizes how important it is to breathe. Breathing is essential for automotive skills, for a human to function in general. But when you're in a panic situation, there are many times when you go into shock and you lose your sense of like your automotive like senses of breathing, which is so basic. So having this deep breathing app and having the panic function is really important because it teaches you to gain control of yourself so that you're able to function properly and do whatever you need to do. So you notice here that we have 3 functions. So we have panic, focus, and stress, all of which are incorporated and they utilize deep breathing. So for the focus one, it's kind of self-explanatory. You would use it to focus. And stress, there's a meter which you can select 1 to 10, and you can you can select how stressed you are, and it will create its own like deep breathing routine for you. And if we have resources, so if I click this shows a lot of resources that you can utilize. So there's phone numbers and operating times which you can call if you want additional help. And if you click on info, it tells you kind of our mission statements more or less. And with that, I want to thank the Eng Wellness Coordinator and especially Dr. Betty, because I'm very grateful to him for this project. And I'd like to thank all my colleagues that worked with me on this. And I would like to thank like the donors in particular, to whoever donated to this project and other projects. You guys have truly made a difference on the Ideas Clinic, and without you guys, I don't think it would have been this successful. So yeah, passing it back to you, Chris.
Thanks, Anthony. And if there aren't any questions, I will pass things back to Dean Wells, who will have a bit more discussion and more possibility for questions.
Thank you so much, Chris, and thank you to our students. I absolutely love seeing all the projects that you've been involved in, and I might need that app when I have to go visit my boss, the provost, for some stressful meetings about our budget at some point soon. So thank you so much. And on a more serious note, I think it will really help our students in terms of their mental health. I was just talking to some first-year students just before this, and many are worried about their physics and chemistry midterms and things. So to have something like this is great. And I think all of you seen through these projects and demonstrations how impressive they were. And I was just so impressed with the students' ability to communicate effectively about them, explain, technical concepts very, very effectively. So I just feel so great about the future when I look at you guys as our future in terms of the next generation of engineering leaders. And I hope all of you that have been on this this call with us have really seen how these direct ties to industry and using this industrial grade equipment, as such as the machine shop behind me and the projects that we've seen, really does offer our students real world design experiences that focus on creative solutions for industries. So again, thank you so much for giving our students a chance to have these experiences. Thank you to our industry partners and corporate sponsors with us today. You are truly making a difference. And I hope you really feel that when you hear from our students and see the kinds of things that we have been able to do with them. With your help, our students continue to gain the skills and the courage to tackle these difficult problems that are facing society, and there are many of them.